if the fog had settled in on the Boston airport 10 minutes earlier, you would have had a free afternoon. We just got out in time. A field of inquiry, no matter what it is established by some array of questions that we pose. And as any researcher knows, asking the right questions is often the hardest part of the task. If you can do it, you may have won more than half the battle. The right questions are those that open up a program of inquiry that leads to insight into problems that are worth understanding. There's no shortage of wrong questions, and in fact they come in many varieties. I'll return to some of them later on. Finding the right questions is harder. Often the right questions are very simple. They invite us to become surprised about perfectly ordinary things, things that we had taken for granted. A classic example of this is the scientific revolution of the 17th century, which essentially set off modern natural sciences. If we're satisfied that an apple falls to the ground because the ground is its natural place and things seek their natural place, then the world will remain a complete mystery. If we're willing to find the fact surprising and puzzling, and the properties of the motion as well, then the door is opened to naturalistic inquiry in the modern sense, particularly if we're willing to adopt what the physicist Steven Weinberg once called the Galilean style, that is, to search for hidden realities that lie behind the misleading and largely irrelevant flux of phenomena. The 17th century also initiated a revolution in psychology, a fact that's less known, or what some people nowadays call cognitive science. And that revolution was also initiated by a crucial act of imagination of a rather similar sort, and specifically by the unwillingness to be satisfied by certain obvious common sense accounts of ordinary things that had long been taken for granted. So suppose I were to draw a triangle on a blackboard, assuming there were one there, and you were to look at it, or suppose, for that matter, that you look up here at where I'm standing. What you would see in the case of the blackboard is a triangle, a certain geometrical figure. What you see when you look at me is a person, a human being, standing and speaking. Now, there was a traditional explanation of the fact. The explanation is that the object in front of you has a form, and that form is transferred to your brain, and it's implanted there. So if you look at a cube and you see it, then there's a cube in your brain. Now, the major scientific contribution of Descartes was to dismiss this traditional explanation as nonsense and to insist that the phenomena merit a real explanation because they are in fact very puzzling. Why should you see a triangle when you look at the blackboard, and why should you see men with hats when you look at something out the window in the street? He argued that that's a puzzling fact and one that demands explanation, and also argued that the traditional explanation makes no sense for a whole variety of reasons. The first reason is that there simply is no way for a form to float through the air and enter your brain. And if you look at the Descartes and other Cartesian writers, there's lots of ridicule of this notion. A second fact is that the stimulus, what you're actually interacting with, is highly impoverished. So, for example, when you look up here, what you're seeing is scattered fragments, and the question is, why do you interpret those scattered fragments as a person? Or if you look at a two-dimensional presentation, you might see it as a cube with depth, and in fact the retinal image is in any event two-dimensional, but you see it as a cube with depth. Or there may just be a sequence of stimuli striking your eye as your eye scans corners and edges, but you see it as a cube. In modern experimental situations, the obvious fact, which it is sharpened up and made even more striking, So, for example, in an apparent motion experiment, a subject can actually be presented with two flashes of light, and what the person may see under certain circumstances, in fact, will see is a line going from one point to another point with no break. If there happens to be a barrier in the middle, it may actually even see a line going around a barrier, although what's actually hitting the eye is just 2 points of light. Or if you're presented with 4 dots, 4 points of light in succession, what you may see is a rigid object in motion, let's say a cube turning in space, and so on in many cases. In short, the stimulus that's reaching you is highly impoverished, but you're seeing something in considerable richness. In the case of seeing a person, it's even more apparent that a lot of richness is being assigned to the impoverished stimuli that are presented to you. Another related point is that the figure that you're presented with is typically a distorted image at best, maybe sometimes highly distorted as in the apparent motion experiments, but at best it's a distorted image of what you actually see, if you like. So, for example, if you're looking at that triangle that I didn't write on the non-existent blackboard, what you would see is a triangle, but what would be there would be something different. It would be some sort of distorted figure, let's say, one line a little bit curved and two of the lines maybe not quite coming together or whatever. But you don't see it as a perfect example of whatever crazy figure it is. What you see it as is as a triangle, or maybe if it's too bad, as a distorted triangle. And that raises questions too. Why do you do that? Why don't you see it as a perfect example of what it in fact is? As I say, the question becomes more dramatic if what's actually hitting your eye is points of light, successive points of light. Furthermore, all of this seems to be done pretty much without any experience. Descartes couldn't prove it, but speculated plausibly that the same would be true of an infant. He said if an infant with no experience were shown a distorted triangle, what the infant would see is that, a distorted triangle, just like an adult wouldn't see a perfect instantiation of what is there, although in real life you're never presented with things like triangles. That's a physical impossibility. David Hume, a century later, looking at the very same phenomena, drew the opposite conclusion from them. He concluded that you have no concept of a straight line, and you have no concept of a triangle. The reason being exactly the same facts. All you're ever presented with are physical things which will never be a straight line, and in fact, if one of them by accident were, you couldn't tell it from a slightly bent line anyway. So therefore, he concluded you just don't have concepts like straight line and triangle and geometrical figure and so on. Well, that's kind of a reductio, and in fact, that followed from his assumptions about the way ideas were formed, and in fact, it's a reductio ad absurdum of these assumptions, since plainly you do have a concept of a straight line and a triangle, and Descartes' speculations about an infant are, in fact, pretty well accurate, as was sort of obvious at the time, and as we now know. It's kind of intriguing. It's an interesting chapter of intellectual history that Hume's reductio ad absurdum of his assumptions was interpreted in the subsequent period as a demonstration of his assumptions, and the alternative, and things went on from there. Descartes' obviously correct interpretation of the same phenomena was pretty much forgotten after some period, and didn't enter into the modern sort of scientific tradition. That's a chapter of intellectual history, but it's fact. Again, if you looking at what you interpret as men wearing hats walking around the street, or a person up here speaking, the problem is even more complex. Why do you see those things as persons? Person is a very strange notion. A person is, what you see is something that has a kind of psychic persistence. So, for example, if, say, my hair were to be combed in the opposite direction, you would take it to be the same person. On the other hand, if, say, or let's say if you look at a person and the person's arm is cut off or replaced by something else, it's the same person. On the other hand, if the person's mind were replaced, let's say by a brain transplant, so that they had different memories and spoke a different language and so on. Presumably it wouldn't be the same person, it would be something else, not the identity conditions would have been broken. And that's the way you perceive things, and that's the way you interpret them, whether it's a geometrical figure or something more complex like a person. And the question is why that's true. It can't be that you were taught it. In fact, if you begin to look closely, you don't even know what the properties are without a lot of work. But those are all aspects of what makes the problem a very puzzling one. And in fact, Descartes was right. These are extremely puzzling facts, and the traditional explanations are completely hopeless. Descartes went on to provide an answer, a proposal. It was a two-pronged proposal. One aspect of it was a mechanistic theory of stimulation on the model of a blind man with a stick. So if a blind man with a stick is poking at the parts of, let's say, a chair, there'll be a succession of stimuli coming to the hand, and it's that sequence of stimuli coming to the hand that are the relevant, that evoke the concept, the percept of the chair. And Descartes argued that when you see a chair, it's exactly the same thing. Your eye scans the chair, and there's actually physical contact because he held that there were small particles, so it's as if a rod extended from the chair to your eye and sort of pushed at it, and there was a succession of stimuli in the eye, and you're exactly like the blind man with a stick. You see a chair because that's what your mind does. And that's the second part of the theory. There's a mechanical theory of stimulation and a psychological theory. The psychological theory was what we would nowadays call a computational representational theory of mind, a picture which said that the mind carries out certain computational processes and forms representations, and it does it on the basis of a rich, innate structure. So you see a triangle or a chair or a person because the resources of your mind create those conceptions as exemplars for interpreting experience on the occasion of very scattered stimulation of the kind that you normally have. The psychological theory then says, in the case of the triangle, that the mind has the principles of Euclidean geometry built into it, and that's why you see the thing in front of you as a distorted triangle, not as an exact example of what it is on the occasion of scattered or even sequential stimulations, and the same would be true of person or of anything else. And the structure itself must be largely built in because it is essentially available independently of experience. So it's on a par with whatever it is about an embryo that gets it to turn into a person rather than, say, a mouse on the occasion of nutritional inputs, or that makes the embryo, if it happens to be a human, undergo puberty at some relatively fixed point in later life, postnatal development, rather than do something else that an organism might do. It's got to be built in, and it's whatever it is can be modified or maybe triggered by something that's happening in the environment. And Descartes argued the same is true essentially of mental life. Well, that gives an answer to a problem sometimes called Plato's problem, namely the problem of how we're able to know so much and to perceive such richness in the world with so little evidence for any of it. And why do we all do it more or less the same way, even though all of us have scattered and different and accidentally different and highly deficient evidence? And in fact, Descartes' answer is pretty much along the lines of Plato's answer, at least partially. The part that's in common is that the experience at most stimulates or awakens or sharpens internally determined mental structures, very much in the way in which nutrition stimulates growth along a course that's determined by natural law, guided by an internal program that would distinguish a person from a mouse. Now, as far as we know, Descartes' answer is largely correct, in principle at least, not in detail. And it was amplified in quite interesting ways through the 17th century and a little beyond. It was then, as I mentioned, largely abandoned, and in fact it was revived not very long ago. By now it's essentially taken for granted in its essentials, A lot is known about the mechanisms that enter into these processes and explain the puzzling phenomena, at least partially. So here we have another case where the right questions were finally asked after a long period, and simple ordinary phenomena were regarded as puzzling, as indeed they are, much like an apple falling from a tree. And when you address them, you set off a course of inquiry, which can actually, in some cases, lead to understanding. Well, the 17th century cognitive revolution raised similar questions about natural language. It also found things that were puzzling and asked for explanations. Now, there's a welter of confusion, but out of it you can detect some pretty similar answers in many respects. Again, the insights, when they were real, were largely forgotten. They were revived only fairly recently, and exactly as in the case of vision, they were revived in complete ignorance of the earlier history, bits and pieces of which were only discovered later. The history really was forgotten, even in the scholarly literature. In fact, sometimes most strikingly in the scholarly literature. The phenomena of language are puzzling in very much the same way, and we quickly find that out as soon as we are willing to find simple facts surprising, like the fall of an apple. In fact, the comment that I made about the word person already suggests some extremely surprising phenomena. Well, take something parallel to vision, take linguistic perception. A signal hits your ear, and you hear a sentence. What you hear is a sentence, say the sentence, John is painting the house brown. Now, the signal that actually reaches your ear could be highly distorted, typically is, could be masked in all sorts of noise, it could be interrupted, it could be from what we call a different dialect, meaning some other language that's close enough to yours so that you can make contact with it, not a determinate notion. And that'll typically, standardly be the case. I mean, it'd be an amazing miracle if any of you shared my language with its special features that come from having been brought up in a particular block in northeast Philadelphia with a father who came from the Ukraine and then, traveled to Boston later and whatever other crazy nonsense forms the way I talk. It doesn't. So you're hearing a distorted signal, but if I say John is painting the house brown, that's what you hear. You hear it the way you understand it and the way you would have said it. Well, what you're creating in your mind, what your mind is creating, is some sort of a complex representation, some sort of a complex object, which is a collection of properties, a collection of phonetic and semantic and other structural properties. That's a linguistic expression, a collection of such properties. You hear it as, and in fact, point by point, the problem is similar to that of seeing a triangle. You hear that noise, that signal, that distorted signal, as a collection of properties which include 6 words. Some of the words sound alike, like the last 2 words, house, brown, sound alike. They're in actually the formal relationship called assonance. They have the same vocalic nucleus. If you made them a little more alike, they would rhyme, like house and mouse. You hear that expression as carrying with it certain entailments. So, for example, if John painted the house brown, then John is applying paint to the exterior of the house, not to its interior. It's kind of curious. If he's applying paint to the interior, he may be painting a room brown, but he's not painting the house brown. And you know that when you hear somebody say, John's painting the house brown. You want to find out if it's true, you look outside, not inside. Now, how do you know, and we can go on, and I will in a moment, how do you know all of these things? Well, it's very much as in the case of, say, the triangle. Experience is utterly inadequate. Even the shallowest investigation will demonstrate that at peak periods of language acquisition, children are picking up maybe a dozen words a day, understanding them in this fashion, meaning they're picking up words virtually on a single presentation. Experimental studies have shown that children will pick up the meanings of words in a very restricted fashion with a lot of richness, even if the words are presented, even if they're in a period of language use where they don't produce sentences, they just produce maybe 2 words, which somebody will interpret as a sentence, but they'll pick up the meanings of words from long expressions, pretty complex expressions that they couldn't possibly produce, nonsense words which are made up for, to test it and so on and so forth. But even apart from experiment, the phenomenon is obvious enough if you're willing to be surprised at things like the fall of an apple. When you look at the acquisition of structural properties or semantic properties of bigger expressions, more complex expressions, the whole problem deepens very, very rapidly. Well, there's only one plausible line of answer, possible direction in which any of these things could be answered, short of miracles, and that's essentially the same as Descartes. His reasoning carries over. And in fact, inquiry into these questions, which begins with the recognition that they're pretty puzzling, inquiry into these questions leads quite plausibly to psychological theory very similar to Descartes, a theory which involves computational representational theories of the mind. The linguistic expression, that full collection of properties, is evoked by scattered stimulation, distorted from your point of view, and you don't understand what your own mind produces on the occasion of that stimulation. Very much like seeing a triangle or seeing a person, interpreting scattered stimuli in a rich and specific way, and you can do it because that's the way you're constructed. You can do it for the same reason that as an embryo you knew to grow into a person and not a mouse. Part of the brain is a set of properties. We don't even hardly know where to look, but presume that they're there, not in the arm. So part of the brain is a collection of structures or elements of some kind, which we can call the language faculty. It has an initial state determined by your biological nature, much the way most everything else about you is. And that initial state becomes a particular language under the impact of the triggering effect and partially modifying effect of rather limited experience, much as the embryo becomes a person through the impact of nutrition. If you're willing to be puzzled about simple things, you now have a plausible research program for naturalistic inquiry. You have a potential science which can give answers, or at least partial answers, to the questions that immediately arise. It's worth noticing that it was only quite recently that these questions were regarded as puzzling. If you go back 40 years ago, say, the standard view was that the problem about language is why it takes so much experience to drive it into a child, given that it's so utterly trivial. The problem was supposed to be one of overlearning. Why does it take years and years for these trivial things to get into the child's mind? The assumption was, well, we understand very well how it's done. It's all done by conditioning, and it's a collection of habits and habit structures and so on. I mean, that is about as plausible as the idea that an apple falls to the ground because that's its natural place, or the idea that you see a triangle because the form of the triangle implants itself in your brain. Even the most minimal inquiry into the facts demolishes that picture instantly. Nevertheless, it was the almost universally held picture. And in fact, in all of the thousands of years of quite fruitful inquiry into language, and it's an old subject, it's, apart from a few blips here and there like the 17th century, it's only quite recently that these problems were regarded as puzzling and problematic and were seriously addressed. Well, what kind of questions do arise if you're willing to face them? First question is, what in fact is the computational representational system in mind, the state that the language faculty attains? Second question is, what is the biologically determined initial state? What's the nature? How does the language faculty start off by virtue of the given program, which is apparently very similar across the species, very slight differences as far as we know, so we can ignore them for the sake of the discussion without anything problematic, at least in this context. Third question that arises is how the computational representation how the computational representational system is put to use in ordinary human actions. Actions like, say, articulating your thoughts, or referring to cats, or telling stories, or interpreting what you hear, and so on. Normal things that people do. Obviously uses this system, but in what way does it use them? Another question you can ask is, what is the nature of the interstate transitions? How do you get from the initial state of the language faculty to successive states, finally, apparently, to a highly stable state after which there isn't very much change, maybe around puberty? What kind of role does experience play in triggering these changes and maybe partially modifying them? There are further questions. There's a question that you might call the unification question. A complex system like the brain can be studied from many different perspectives at many different levels. You can study the brain in terms of, say, atoms or molecules or cells or cell assemblies or neural networks or computational representational systems. At any of those levels, you may or may not be able to construct a true theory about what the brain is and what it's doing. If you can construct a theoretical explanatory account which merits a certain degree of faith, you can then ask the unification question. How do these various levels of inquiry relate to one another? Well, for now, there's really only one well-grounded theory as far as things like language are concerned, and those are the computational representational theories. We assume, essentially on faith, that there's going to be an account of all of this in terms of, say, atoms or cells. With a much greater leap of faith, one may assume that what's involved in all of this is neurons and networks of neurons, not, say, the vascular system, although there's plenty of blood flowing around in the brain, a lot more than one might expect, enough to lend some credibility to Aristotle's thesis that the purpose of the brain is to cool the blood. Still, we tend to assume, with a huge leap of faith and basically no evidence, that the neurological structures, not the vascular ones, are somehow implicated in all of this. There is, incidentally, a kind of a common slogan in the so-called cognitive sciences, which runs something, says that the mental is the neurophysiological at a higher level, so we don't have to be scared about the mental, where the mental includes things like computational representational systems. Well, that slogan has the story backwards, at least from the point of view of the natural sciences. From the point of view of the natural sciences, what we ought to say is we ought to have a tentative hypothesis, recognizing there's very little evidence for it, and the tentative hypothesis would be that the neurophysiological is the mental at a lower level, lower in quotes, where the mental is the only one we have any faith about from the point of view of the criteria of science, at least, because it really does have reasonably rich structure of explanatory theory that accounts for things. That would be the realistic approach, and one might even hope that the theories, that the theoretical apparatus, theoretical perspective that does seem to have reasonable grounding in empirical fact and explanatory wealth, that it may provide the guidelines for inquiry into what it is about the brain that makes it have these properties, possibly along the lines of, say, chemistry in the 19th century, which studied things in the world from a rather abstract point of view, like valence and periodic table and organic molecules and so on and so forth. The physics of the day the unification problem was wide open. Nobody knew how that related to the physics of the day. And in fact, it turned out it didn't relate to the physics of the day because the physics was completely deficient and had to be radically revised in order to accommodate those properties. That could turn out to be the case here too, or it could turn out to be the case that we have something on the model of, say, genetics about 40 years ago, where it turned out you could do something like reduction instead of what you might call expansion, as happened in the chemistry-physics case, or there might be something else. There's a unification problem, and you never know in advance how it's going to be settled, if at all, at least if you're following the principles of naturalistic inquiry, the principles of the sciences. Well, what kinds of things do we find out if we try to address these questions. Let's, for simplicity, keep to this sentence, this linguistic expression. John is painting the house brown, which, recall, is a certain array of phonetic and semantic and other properties. Well, what we find out is that some properties of that expression are universal, which means they're unlearned. Others are particular, are language particular. They are selected by experience from some innately determined set of options, which turns out to be a rather narrow set. So on the phonetic side, it's a universal property of that expression that the vowel of the word house is shorter than the vowel of the word brown. On the other hand, the quality of the vowel within some range is language particular. So for me, it's the same as the vowel of hat, and for you, it may be some other vowel in that rough range. Turning to, say, semantic properties, one is the one I mentioned. A brown house has a brown exterior, not interior. That appears to be a universal property, not just of that word, but of a whole big category of words, roughly container words, including ones that we might invent. So it's true of words like box or airplane or igloo or lean-to or spherical cube or whatever you might choose to consider. If you're painting a spherical cube brown, you're giving it a brown exterior, not interior. That appears to be a universal property. A particular property is the one that distinguishes the word house from the word home. So in English, say, if I go after work, I go home. If I was talking Hebrew, I would go to the house. If you take a closer look, you find a good deal more complexity, determined by the computational representational systems, and in fact, really determined by their innate fixed structure. So consider again the fact that the exterior surface of a house, or any similar word, is somehow distinguished. That carries over to a lot of other things. If you see the house, you're seeing its exterior surface. We can't see this building from here, although we could see the building. Let's say if a piece of it was, let's say I was in an airplane, analogous case, you could see, you're sitting inside it, you can see the airplane. If, say, you can look out the window and see the wing, then you can see the exterior surface. Or if there was a mirror outside and was reflecting the exterior surface, you could see the house or the building or the airplane or the igloo or the spherical cube or whatever. So basically these things are geometrical entities, exterior surfaces. It's a very strange way to look at things, but that's the way we look at that's the way we use, that's the nature of these conceptions that we use to talk about things. On the other hand, the house is not just its exterior surface, that is a geometrical entity. So for example, suppose that, say, Peter and Mary are equidistant from the exterior surface, but Peter is inside the house and Mary is outside the house. Well, Peter, the one inside, is definitely not near the house. Mary could be near the house, depending on what the current conditions on nearness is. Similarly, the house has chairs inside it, not outside it. So the house involves its exterior surface and its interior. However, the interior is very abstractly conceived. So, for example, if I fill the house with cheese, or say I move the walls, it's the same house. On the other hand, if I clean the house, I may be interacting only with things in the interior space. So the house is conceived as an exterior surface and an abstract interior space with quite complex properties. Of course, all this time, the house itself is a concrete object, and we know that perfectly well. The house can be made of bricks or wood, and a wooden house is not one with a wooden exterior, in contrast to a brown house, which is one with a brown exterior. We can look at a house from both of those perspectives at once. So a brown wooden house has a brown exterior, looking at the house abstractly as a geometrical surface, but it has it's made of wood, taking the concrete perspective. If my house used to be in Philadelphia, but it's now in Boston, then a certain physical object was moved. In contrast, if my home used to be in Philadelphia and is now in Boston, then no physical object was moved. Although my home is also concrete, so my home is made of bricks or wood or whatever, it's some physical structure. House is concrete in quite a different way. My home can be the house in which I live, or the town, or the country, or the universe. That's not true of house, though they're both concrete. Now, that house-home distinction has numerous consequences. I can go home, but I can't go house. I can live in a brown house. I can't live in a brown home. In many languages, the counterpart of the word home is essentially an adverb, which is pretty much the sense in case in English too. All of these are aspects of our concept of house. And that, wherever we look, we find exactly the same thing. So whether something is, say, a desk rather than a table or a hard bed depends on such things as the intentions of its designer or the ways in which people intend to use it. Or take, say, a book. A book is a perfectly concrete object. You can refer to books that way. You can say, for example, this book weighs 5 pounds. Or you can refer to books from an abstract perspective. You can ask who wrote the book, which is not some physical object. Or even he wrote the book in his head, but then he forgot about it. Or you can refer to a book from both perspectives simultaneously. You can say the book he wrote weighs 5 pounds, or the book he is writing would weigh 5 pounds if he were to finish it, let's say, and it were to get published. And the same is true, again, wherever you look. So take a city like, for example, London. London isn't a fiction, it's something non-fictional, but when you consider it as London, that is, through the perspective of a city name, a particular kind of linguistic expression, then you give it very curious properties. So London could be completely destroyed, and it could be rebuilt up the Thames in 1,000 years, and it would still be London under some circumstances. You can regard London with or without regard for its population. So from one point of view, it's the same city if all the people desert it. From another point of view, you can say that London has come to have a harsher feel to it through the Thatcher years, which is a comment on how people act and live. And two such perspectives on London can fit quite differently into a system of beliefs that yield some of the puzzles of the philosophical literature. Puzzles that might very well dissolve, incidentally, if we abandon some of the assumptions on which they're based, such as the assumption that there is a relation of reference holding between words and things, or that there's a common language from which those words are drawn, assumptions which are very far from obvious, I should say, and in fact don't even seem coherent. Well, even in these trivial examples, we see that the internal conditions on meaning are rich and complex and unsuspected, in fact barely known. The most elaborate dictionaries don't even dream of such subtleties. These concepts are acquired by the child in their full richness, and the only possible explanation for that must be that they were already there. There are only marginal modifications of the kind illustrated, and I stress again that these are very trivial examples. When you look at harder examples, it becomes even more obvious. These are some of the notions that seem most concrete, but they're already off in a domain of quite considerable complexity, predetermined complexity. Now, there seems at first glance, at least, to be something kind of paradoxical in these conclusions. So take houses and homes again. They're concrete, though they're concrete things, houses and homes, but they're concrete in quite different ways. From another point of view, also, we consider them to be quite abstract, though again, abstract in very different ways. It's not that we have confused ideas or inconsistent beliefs about houses or homes or igloos or boxes or spherical cubes or whatever. Rather, lexical items provide us with a certain perspective for viewing what we take to be the things in the world, or for that matter from the constructions of our mind, what we conceive in other ways. They're kind of like filters or lenses. They provide a certain way of looking at things and thinking about the products of our minds. The terms themselves do not refer, but people can use them to refer to things, viewing them from a particular point of view, through a particular lens, if you like. It's a point of view which is quite remote from that of the natural sciences, which seek to divest their concepts of all of these parochial human interests and concerns as far as possible. Well, these are trivial cases. When you move beyond lexical structure, the conclusions about the richness of the initial state of the language faculty and its apparently special structure are reinforced very considerably. So to take such expressions as, say, he thinks John is a genius, and compare it with John thinks he is a genius. In the first case, you take he to be somebody other than John. In the second case, he could very well be John. He thinks John is a genius versus John thinks he's a genius. Well, that's not the effect of linear order. For example, in the sentence, his mother thinks John is a genius, you can again take he and his to be referring to John, and typically you would. So there are some kind of structural conditions that determine what you might call referential dependence, whether a pronoun can pick up its reference the way you use it to refer from some noun phrase in the sentence. Now, the principles underlying those facts appear to be universal, at least in large measure, and when you pursue them, they yield rich conditions on semantic interpretations, on intrinsic connections of meaning among expressions, including, incidentally, analytic connections. Furthermore, in this domain, you begin to have theoretical results of some depth, which pretty surprising consequences. So the same principles appear to play a significant role in yielding the semantic properties of expressions that are superficially quite unlike these. Take, say, the sentence, John is too clever to expect anyone to talk to Bill. And ask yourself, who's doing the expecting, the non-expecting? Well, it's John. John is too clever for John to expect anyone to talk to Bill. John is expecting no one to talk to Bill. Suppose you take the same sentence and you drop the final word. John is too clever to expect anyone to talk to. Well, then everything changes. Then you're talking to John, and it's no longer John who's doing the expecting. It's somebody other than John. And that same property holds for a huge class of other constructions. And it seems that the principles that explain those curious interpretations are pretty much the same principles as the ones that deal with referential dependence, as in the examples before. Well, at this point, you're reaching to quite non-trivial properties of the computational representational system. Phenomena that look totally dissociated can be accounted for on the basis of simple and pretty elegant and pretty far-reaching principles which interact to yield some quite complicated results. At that point, one is really learning something about the nature of the language faculty. Well, I won't proceed with other examples, but that's what you get into as soon as you take the question seriously and try to give answers to them instead of waving your hands about overlearning and habits and forms flying through the air and things falling to their natural place and so on. What kinds of conclusions does one reach from this inquiry? There are a number of pretty plausible results. One of them is that a language consists of two different parts. One is the computational representational system. The other is a lexicon, a collection of things like house and London and so on. The computational system takes an array of items from the lexicon and it converts it into a linguistic expression like John is painting the house brown or John is too clever to expect anyone to talk to, with its full array of phonetic and semantic and other properties. And if that's the case, there are going to be two acquisition problems. There's a problem of accounting for the growth of the computational system and accounting for the growth of the lexicon. And these two problems look in some ways different. As far as the computational representational system is concerned, it's possible that the answer to the problem is trivial. That is, that there's only one, that the initial state of the language faculty only has one instantiation. There's only one possible computational representational system, and in this respect, only one language. With regard to the lexicon, it can't be quite like that, but it may be surprisingly close to it. One part of the lexicon is concepts like, say, house and person and desk and so on. And it may be that these are fixed, that they don't allow much or maybe even anything in the way of variation, and somehow given, although we don't know a lot about the principles that enter into them. The selection of them, of course, will be language specific. So we've selected in childhood house, and others have selected igloo, but the properties of these expressions are remarkably similar, and what's similar about them is apparently predetermined. Beyond that, there's what's sometimes called Saussurean arbitrariness. After Saussure, that is, you can pair up concepts and phonetic sound representations in arbitrary ways. That's the sort of trivial part of language variation. There's also variation among what are called grammatical elements, things like, say, case. So if you study Latin, you got to memorize all sorts of paradigms and, you know, where you use what the form of the accusative case is and fourth declension and all that kind of business. And similarly with verbal inflections and so on. And there's some difference among languages in this respect. So when you're learning English, you don't have to do all that stuff, or so you think. Actually, chances are that English is very much like Latin in this respect. And maybe all languages are very much alike in this respect. And the only difference between them is what comes out the mouth. So that's very likely that the Latin-type systems, in fact, are there in English. It's just that they're all done by mental computation. They have pretty much the same, often far-reaching consequences that the systems have in languages where you see them, you hear them come out the mouth. But it's just that the mental computations feed the articulatory apparatus at a different point in the computational system. Hence, you get what appear to be very different languages, although from the point of view of a, say, rational Martian, the differences would be pretty trivial, just what comes out the mouth, not what's going on in the internal computations. If that's the case, then the differences among language would reduce to some of the lexical selections, the Saussurean arbitrariness, choices in grammatical elements, which may very largely have to do with what is articulated, not what is computed. Of course, very small differences in an intricate computation, and then only one computational system, only one technique for converting all of this into expressions with a rich array of properties. And then some differences on the phonetic side. Notice, incidentally, you'd expect more possibility of difference in the phonetic side of the system than in any of the others. And the reason is that it's only the sound side of the system that you actually get very much evidence about. Not all that much, but at least some. At least you hear the signals. The rest of it you all just have to basically make up. And since you have to basically make it up, it must be that most of it is built in. So you'd expect more variation on the sound side and on the Saussurean arbitrariness, where you do get direct evidence, that on most of the other things, in fact, anything I've been talking about. And that appears to be the case. Again, going back to the Martian scientist, if the Martian scientist approached humans the way we approach, say, fruit flies, the Martian scientist would presumably conclude that they're basically all identical. The languages they speak are all the same. There are some marginal variations, like there might be some differences in the fruit flies in a sample, which you'll overlook for the purposes of the experiment. That looks closer to reality than one might have anticipated not many years ago even. Notice that very small changes in an intricate system can yield what appear to be substantial phenomenal differences, but they may be highly misleading. They may be just different modifications of the essentially same thing. And that looks very largely true. Well, another thing that you find and must find is that language is embedded. Language is just some kind of mental computation, some computational properties of the brain, computational representational properties of the brain. And it's embedded in performance systems, at least in humans. These are systems which use all of these resources for various human actions, things like articulating your thoughts, or for interpreting what you hear, or for talking about cats, or for telling jokes, or whatever else you do with these things. The reason it makes sense to call these computational systems language is because of the performance systems in which they're embedded. In principle, if might be biologically impossible, but in principle there could be another organism which would have the very same language that you do, this very same internal system, but would use it as instructions for locomotion, just embedded in different performance systems. In that case, we wouldn't want to call it a language. The language, in other words, is a real thing. It's a state of the brain, we assume, And as such, that real thing could be integrated in different kind of systems. Ours happens to be integrated in a system for articulating thoughts and referring to cats and interpreting what you hear, and hence the study of all of this is language. If it were integrated in something else, we couldn't call it that. It's even conceivable that some other organism has this system completely, and there just aren't any performance systems that access it. So the organism has the capacity for, has language, in fact, just no way to access it. And you'd have to find that out in some other way, some more indirect fashion. That's by no means an absurd possibility, though it probably isn't true. The performance systems appear to be of two different categories. There are, on the one hand, receptive systems. On the other hand, there are productive systems. The receptive systems take a signal in a collection of an array of circumstances. They have access to the language. They produce an expression, a linguistic expression. So you hear a signal, John is painting the house brown, in the particular circumstances you're in. Your perception says your receptive system accessing the computational, your interpretation of that expression with its sound and other properties. The problem of investigating this is beyond inquiry, but you can proceed to some idealizations that may make some sense. The standard idealization is to assume that there's what's called a parser, which just takes the signal, forgetting about the circumstances, accesses the language, and produces the structural description on that occasion. It's also typically assumed that the parser is invariant. That is, it's the same for all languages, and it doesn't grow the way language grows in childhood. The main reason for assuming that is ignorance. Nothing much is known about parsers, so you make the simplest assumption, which is there's only one and it never changes. In fact, the whole idea of a parser, the existence of a parser, is much more questionable than the existence of the language that it accesses. That's almost hard. It's very hard to imagine that that's not true. It's almost incoherent to question that. On the other hand, a parser might very well not exist. There might not be any part of the brain that just uses signals, accesses linguistic knowledge, disregards circumstances, and comes out with an interpretation. It's a guess that such a thing exists. It may. There are lots of other it's commonly the opposite is assumed. It's very commonly assumed that the parser is uncontroversial. The problematic part is the so-called competence, the language. If you think it through, it's just the opposite, at least, again, on scientific grounds. There are other assumptions about parsers which are common, but don't withstand even the slightest inquiry. For example, it's commonly argued, and you can find this all over the literature, including the linguistic literature, that parsing is easy and quick. You do it very fast and very easily, so therefore the language must be very well designed for parsing. And in fact, the criterion for a theory of language must be that it explained this fact that you can parse so quickly. You do it so fast, in fact, almost instantaneously when you listen to what I say. The problem with that thesis is it's just flatly false empirically. Parsing is extremely difficult very often, and often quite impossible. And there's whole categories of expressions which are well known and which are studied precisely for this reason. They're given various kinds of names like garden path sentences or center embedded expressions and all sorts of others. In fact, even ones like the one I gave you, John is too clever to expect anyone to talk to. People often find that rather slow parsing. It takes time to figure out what it means. Parsing is anything but easy and quick, and it's often what's called wrong, meaning what the perceptual apparatus produces is different from what the language tells you is the actual structure of the sentence. Anyone who's taught elementary logic is familiar with this. Give people, even professional mathematicians, sentences that have a negation and a disjunction in them, and their parsing goes way out of whack. This is so extreme that even some of the common idioms of our language are interpreted as meaning the opposite of what they literally mean. So if two airplanes come close and almost hit, we call it a near miss. But think it through in your spare time, and you'll notice that it's a near hit. If it was a near miss, they hit. But just even the slightest introduction of something negative, and our parsing apparatus collapses. When you look at more complex structures, it's off the wall. So parsing is anything but easy and quick. It's very often very difficult and often, in fact, impossible. So how come we can communicate so readily? Well, we just use the parts of language that are readily parsed. Some parts of this system are, in fact, very easily parsed. Those are the ones we use. And those are the ones that, since other people are just like us, they don't have any trouble with them. So certain parts of the language are usable, and the parts that are usable are used, and that's it. Like tautologies. Beyond the tautology, there's nothing to say about this. As to the idea that language is well designed for parsing, not only, it's hard to say that it's false because it's not even clear that it's meaningful. To talk about what a biological system is designed for or adapted to presupposes gives some promissory notes that can't be filled. It assumes you can only talk about what a system is well adapted to if you had some space of possible systems and of possible functions and some metric that said pick an arbitrary system out of there and an arbitrary function, and there's such and such a likelihood that they'll be adapted to one another. And then if you could show that the system you have in mind, say the kidney or language, is better adapted than a pair of systems and functions picked at random. If you could go through any of those steps, you could talk about when systems are well adapted, but that's all fantasy. You can't talk about any of these things. So it's not clear that it even means anything to say that a system is well adapted to a function, at least in any useful sense. In any event, if you can make some sense of that, it's not going to turn out that language is well adapted to the to the function of communication, because it isn't. You only use the scattered parts of it that have that property. Turning to the matter of production, there's very little to say. This was, in fact, a crucial point in Cartesian philosophy. In fact, the criterion of mind was held to be, one of the major criteria of mind was held to be the capacity to produce linguistic expressions, to express thoughts in the manner in which humans do it. And that was held to be outside the bounds of mechanical explanation, and the general idea may very well be sound. Anyway, there's nothing much to say about it except at the level of sound structure. There are other questions. For example, the unification question, the relation of the well-grounded computational representational systems to cells or conceivably neuronal networks or whatever's the right array of mechanisms. That pretty well lies in the future. There are questions about evolution of such systems. That's there. It's doubtful that the questions are even being put in the right way. Anyway, there's nothing to say about it as far as I know. Well, that's a kind of a quick tour through some of the right questions, or what seem to me the right questions, right because they lead us to inquiry that provides insight into matters that are worth understanding, and do it in the naturalistic style, with the rational expectation of ultimate integration into the natural sciences, maybe by modifying some of their assumptions as in the past. There are also plenty of wrong questions that lead nowhere for all sorts of reasons. To mention a few possible reasons, some of the wrong questions are wrong because they're just premature. You just don't understand enough to know how to proceed. So, or perhaps you could imagine how to proceed, but inquiry is barred in other ways. The unification problems like that, the problem of relating computational representational systems to the brain sciences. Not enough is known about how the brain, what mechanisms, you don't even know what mechanisms of the brain to look for pretty much at this point. Maybe study of computational representational systems will provide some guidance on that, but right now it's questions up in the dark, and to the extent that you can think of ways of studying it, you can't carry out the methods, so you're not going to carry out, say, ablation experiments and so on. Interestingly, there are non-intrusive methods, which are giving some kind of intriguing results, relationships between event-related potentials, electrical activity of the brain, and surprisingly subtle aspects of linguistic structure. And maybe something will be learned about all this, but at the moment it's mostly, it's premature at least. There are also problems which are of the kind that are often called too many variable problems. like the problem of determining the course of a falling feather, or just about any phenomenon of ordinary life. So, for example, the actual state of, say, John's language faculty is not worth studying. That's some weird jumble of systems reflecting the accidental course of his history, about as interesting as the course of a feather. How John interprets what Peter has in mind when Peter says something or other in particular circumstances, that's also so rich in relevant factors that it's not worth studying, like most phenomena of ordinary life. There are other questions that just fall beyond the scope of the system under investigation. So suppose you're taking undergraduate physics and you're in a mechanics class and you're doing an experiment rolling a ball down an inclined plane, and the lab manual has a prediction that it's going to take that amount of time to roll down. Suppose somebody falsifies the prediction by reaching over and picking up the ball and throwing it out the window. Well, that didn't count for some reason. It was the person who threw the ball out the window was outside the system, so you didn't refute physics by that experiment. Actually, to answer the question why you didn't refute physics is not so trivial. You might want to think about it. But we assume that you didn't. The system is somehow closed, and things outside it, even physical mechanisms like people outside it, they don't count. And there are a lot of questions like that. They're not easy to sharpen up, but we just recognize them, often at least. If you want to account for, say, which linguistic expressions are amusing or verifiable or refer to cats or something like that, that's just outside the scope of the system. Like reaching over and throwing a ball out of the window when you try to refute a mechanics experiment. In this domain, you often find questions that don't have general answers, though they might very well have answers relative to specific circumstances, usually to specific human interests and concerns. Trouble is, these can vary in every imaginable way, so there's nothing of any generality to say about them. Take, say, the idea of John and Bill speaking the same language. Well, under particular conditions, we can give an answer to that. So I could say of somebody in the audience, that person and I speak the same language, but somebody in Tokyo, we don't speak the same language. The problem is there's no general answer to that question. It's like the question, is Boston near New York? Well, from my point of view, no. If you live in London, maybe yes. There's no right answer to whether Boston is near New York. Or does John look like Bill? From certain points of view, yes. From certain points of view, no. These aren't questions that have answers or could have answers. There are no idealizations. There are no natural categories. There are no natural neighborhoods, if you like. Those are just highly interest-relative questions, perfectly usable and fix the circumstances, but trouble is circumstances can vary in every conceivable fashion. Notions like common language or public language that people know, or as often claimed that people partially know, to talk about that makes about as much sense as an effort to determine objective height categories or neighborhoods or lookalikes or something like that. Sometimes it's argued in the literature that you have to assume a common public language or you can't account for the possibility of communication. But that's just a fallacy. In order to account for the fact that John and Bill look alike, you don't have to postulate a common form that they both share, and to account for the fact that John can sometimes interpret what Bill says, you don't have to postulate any mystical concept like a common language that they both share or maybe partially know or anything like that. That doesn't seem to make any sense at all. Very likely, although here the territory is more obscure, the same is true of the notion of reference. That is, a relationship that holds allegedly between words and things. So, for example, suppose you ask what the word water or house or London or one of these things refers to. Looks as though that question is meaningless without further specification of circumstances. You can say that words are used to refer, and in fact used to refer in a manner determined by their internal semantics from a particular perspective or vantage point, say as a person or as a house or as a desk or as London or something like that. But it doesn't seem to make any sense to ask general questions about the reference of a word or a phrase abstracted from those conditions, or about reference and its nature, as if it were something like looking alike in its nature or being near in its nature. If that's true, and it does look to be true, then it will also make no sense to seek some notion of content, which is understood as a property of an expression that fixes its reference. That's been a major topic of the philosophy of language since Frege, but it's not so clear that there's an actual topic there. Also, it wouldn't make sense to ask what's the meaning of a word, just as we can't ask what's the sound of a word. A word has a sound in particular circumstances and occasions, but there's no such thing as the sound of a word. And it's not clear that there's anything more to say about the meaning of a word. Though the properties of the uses, the sound articulations and the uses in a variety of human actions, those are very narrowly fixed by rich internal properties of the kind that I've indicated. You can talk about how a word is used to refer or how it's used to pronounce, but it's not at all clear that it makes any sense to ask about its meaning or its sound or its reference or anything like that. Now, a good deal of the modern study of language relies on such notions as common public language or reference or content and so on, and that in fact includes much work, a lot of work of great sophistication, a lot of work which is in fact illuminating in many ways. Nevertheless, the reliance on these notions, in my view, is much too uncritical, and it's not at all clear what would remain if what seem to be quite dubious props are kicked away. Now, there are other categories of wrong questions that are worth noting. For example, you can ask pointless questions using technical concepts that no longer lack any clear sense. So, how much phlogiston is there in that fire over there? Or questions about vital force, or questions about material body. Those are all terms that at one stage of science had a certain meaning. They fit into a quasi-explanatory schemes, but they no longer do. And you can't make any sense out of sentences, questions like, are computational representational systems material, unless you somehow resurrect these abandoned notions. There are also problems of what's sometimes called epistemic boundedness. Humans are, we assume, biological organisms, not angels, and as such, there's going to be certain, they have certain capacities which are fixed. They may be very rich, like the language faculty. Very rich faculties enable you to do very many things, but they also exclude very many things, namely the ones that don't conform to those rich faculties. And whatever faculties of the mind are involved in, say, doing scientific inquiry or solving problems and so on, there's only two possibilities. Either they're so vacuous that we can never do anything, or they're structured, in which case there are a lot of things we can't do and other things we can do well. That's true of every organism we know. So, for example, rats can do some things well, but by that very token, other things badly. And if we're part of the natural world, the same is true of us, which means that there will be questions that are posable that are beyond our intellectual grasp, though some differently organized intelligence might have no problem with them, just as we can deal with some of the problems that rats can't face because they don't have the right concepts in principle. Now, that means there's got to be some, assuming we're part of the natural world, there will be some notion of epistemic boundedness. There will be some pure mysteries. Just, you can maybe pose the question, but can't do much about it, like a rat trying to run a prime lumber maze. Within the domain of, and we don't know what those bounds are, although conceivably you could learn about them. There's nothing self-contradictory in assuming that we might even come to understand those bounds. Within the domain of reasonable questions, there is a naturalistic approach that doesn't appear to raise any questions of principle, at least beyond those of the natural sciences generally, and has some sometimes far-reaching, sometimes surprising results about the human language faculty, about its nature, about its acquisition, about some of the ways in which the mechanisms are available and sometimes put to use. These, so far at least, progress along these lines has mostly been at the computational representational level, but not entirely. There are many questions that we can formulate, but we can't even begin to answer. Some of them are doubtless quite real, we just don't understand enough. Some are perhaps only apparently real, maybe pseudo-questions on a par with how do things work or why do they happen. Questions that have the form of questions but only indicate areas of inquiry, and there are many different kinds. I've mentioned a few. One has to somehow be able to avoid those and identify and focus on the real questions, the ones that yield a successful and productive line of research inquiry. We know of some cases. There are others where we remain pretty much in the domain of mystery. Thanks. I think there's some mics around if anybody wants to talk. There and there. Three, in fact.
Yeah, Ralph T., the University of North Carolina. I just wanted to ask you whether you have any evidence that the lexicon is in fact distinct from the mental, computational, representational complex? Or are lexical representations also computational?
Is the lexicon separate from the computational apparatus? Well, it depends. I think it's not so much a question as a matter of bookkeeping. It's all computational representational. Okay. But the question is whether the computational representational system falls into two radically different categories in terms of its properties and its characteristics and so on. And that seems to be the case. That is, the lexicon seems to have, it does have computational properties, but they look very different from those of the, sometimes called the syntax. Now, there are some real questions there. Some very interesting questions. For example, take a word like, say, shelve, as in John shelved the books, meaning John put the books on the shelf. Doesn't literally mean that, but it means something kind of close to that. Shelve is a word, and the question is, in the real world, the world in your head and in my head, does our computational system reach into the lexicon, pull out the word shelve, stick it in that position, or does it take some much more abstract representation and form John shelved the book? And there's evidence of the latter kind in that case. Interesting and subtle evidence. So in that kind of sense, some of the things that we might in advance think of as being in the lexicon, we might have wrongly placed. Maybe they aren't in the lexicon. But it does seem very plausible to believe that there is a fundamental conceptual distinction between an array of elements there to be picked out and a computational procedure which picks them out and does things with them. What's in that array, that's open to question. For example, does it include the word shelve? Does it include the word break, as in John broke the window? Or is that formed by some operation? And similarly for lots of other cases. So it's the choice of what's in it is not entirely clear by any means, but the conceptual distinction looks reasonably clear in the sense that there just isn't any other coherent account of what goes on. Yeah.
I'd like to ask you a less technical question, perhaps. Do puns tell us anything about language?
Do
puns?
Puns?
For example, if I said Professor Chomsky doesn't like my language, are you referring to maybe the curses I've heaped on somebody, or to the language I'm using, or the particular language I speak, or whatever? Do these occur in all languages, or some? And particularly, I'm wondering if there's any significance to why some people like them and some people hate them.
Those are all perfectly real questions, but they have the form of questions, let me say, but it's not clear that they are yet real questions. I mean, so like one could ask, would observations of the moon taken from Jupiter be useful evidence about physics? Maybe, you got to show that it is. There's no way of knowing in advance what kind of phenomena are useful evidence. Things become useful evidence when somebody can figure out what to do about them. As far as puns are concerned, notice that they have to do with language use, not with language itself. You can't really ask whether every language has puns. You can only ask whether every language user does use puns, or whether every language user has the capacity to use puns if that capacity is probably awakened. The answer to the second question is probably yes. The answer to the first one is probably no. It's not clear what we learned from that. What makes something a pun might or might not be illuminating. You'll only know when somebody gives the answer, like any other kind of phenomena.
Under a theory of universal languages in which all languages are essentially the same, how would you approach the traditional claim that in every language there are certain words that are considered to be untranslatable, and that sometimes there are entire works of literature, such as the Quran, which are considered to be untranslatable?
Well, you can't really answer that because the notion of translatable doesn't mean anything. It's a little bit like the notion refer. At what level are you translating something properly? Like when you hear me say, John is painting the house brown, and you're interpreting what I say, are you giving a translation or a different interpretation? There's no answer to that question. That's like, is London near Cambridge? The question only has answers relative to certain specific human concerns. Relative to certain kinds of human concerns, a sentence in one language, in, say, my language, may or may not be translatable into your language. I may have different associations. I may embed it in a different array of interests and understanding and so on. But we have no question, so you can't give an answer. I mean, there are certain things that you can give answers to. There are other questions which just aren't answerable for the kinds of reasons I mentioned. Similarly, you couldn't say whether they're like answering the question, what makes a feather fall on a particular course, or even worse questions than that. When people talk about translatability, they're talking about cultural wealth at a level that goes way beyond this discussion.
I wanted to say that I always had trouble when I was growing up learning the difference between house and home. So I didn't know if I got it in one pass when I was growing up.
I doubt that very much, frankly.
I wanted you kind of during your talk you assimilated theory that the stimulus is impoverished and we have to construct it internally to Descartes, and referred in passing to behaviorism and implied that it sort of had the opposite sort of take on the issue, that why does it take so much stimulus to sort of get for a child to learn the concepts, linguistic concepts. And I was wondering if you would comment on, say, other theories of that involve rich stimuli. I'm thinking of Gibson's ecological realism, and why is it not as naturalistic approach? Why is it not naturalistic to look for properties of the environment, say properties of the environment that would correspond to a container object, instead of saying that structure is in a language faculty?
Well, the problem with that is that you can perfectly well say that houses, those things in the environment, have all the properties that I mentioned. That's true. Houses are the physical thing out there. It has the property of eliciting a point of view which says you're just an exterior surface, and it has the property of eliciting the point of view that says you're an exterior surface plus a distinguished interior with abstract properties. And it has all of those properties. Must have them. In fact, it has exactly the properties that enabled me to think about it in that way. But the trouble is it also has every other array of properties. Has any array of properties you like. If I design a different organism that decides to look at a house with a distinguished interior surface, and some other property, the exterior plus things 10 feet away, has that property too. So you're back to the question, why do I pick out that set of properties? And the only answer to that, short of, divine intervention, has got to be that it's coming from inside me. So we're back to the same theory. There's only the appearance of a different approach there. That's self-delusion.
There seems to be an assumption underlying your theory of natural language that there's a close link between the signifier and the signified. That, I guess, to use your analogy to Descartes, that when you and I both look at this figure, we both see a perfect triangle, that you're not seeing a triangle and I'm seeing a square. One thing that I'm interested in, if you do agree that this is an assumption that underlies this, why do you make that assumption?
Because it's true.
And also,
I mean, it's overwhelmingly supported. I mean, it's not always true in every possible case, but in the case of, in Descartes' case, looking at a triangle, it's true, and you can demonstrate it in the laboratory.
How do you respond then to, say, post-structural theorists who come from a radically different assumption?
Well, if I understood what they were talking about, I guess I could respond. But not understanding what they're talking about most of the time, I can't respond. I mean, if somebody can make a coherent, can present to me, I mean, I won't say that I don't understand anything. I mean, there are some things that I read and they kind of evoke images and associations in my mind that I can sort of make up a story and say, well, it probably means that. It usually turns out to be something pretty obvious, such as the fact that your interpretation of a text depends on, all sorts of things that you're bringing to it, or that the environment, that the history is bringing to it, and so on and so forth. Sure, that's obvious. When I try to understand something, to try to find something non-obvious, I can't find it. Maybe that's my defect, like maybe I'm lacking a gene or something. But anyway, when I read it, that's what happens. I should also say that I have, there are a lot of things in the world I don't understand. So, for example, if I pick up the latest issue of the Physical Review, and I read one of the articles in it, or, some set theory journal, I'm not going to understand it either. But there's a radical difference between these cases. In the case of the Physical Review, first of all, I know that if I made the effort, I could get to understand it. And I know what course to undertake to get closer and closer to understanding it. I've done it in cases which I happen to be interested in. Furthermore, I know that I can go to my friend in the physics department and say, look, this looks like total gibberish to me. Explain it to me at my level of ignorance and stupidity so that I'll be able to understand it. And he can do that, On the other hand, when I try this with a page of Derrida, nobody can explain to me what it means. And I don't know what process to go through to get it to be other than just words spinning around on the page. So maybe it's some new variety of human intellectual achievement that goes beyond quantum physics and set theory and all these other things. But anyhow, it does look qualitatively different to me. That, as I say, maybe that's my defect. But that's why I can't answer the questions.
Dr. Chomsky, if I understand correctly, you hypothesize a natural language that's kind of a functionality in the brain, and what we actually speak is kind of a simple epiphenomenon on top of that, and that the actual language is more complex and rich than we actually ever use. Do you have any hypothesis on how all this excess capacity came to be there?
Yeah. So, it just seems to be a fact that our language capacities involve, some things just seem to be factually correct. Say that there are garden path sentences. There are sentences where our mind, the mechanisms of our mind, assign to them a certain set of properties. But when we perceive the sentence, our interpretive capacity doesn't assign them those properties. We have to go through some other course of inquiry using our scientific capacities and so on to notice that discrepancy. There seem to be things like that, and that just looks well established. So why did it happen? Why did we get this system? That's like asking how we got anything else. Why did we get a circulatory system? Why do we have arms? Virtually nothing is known about those questions. I mean, there's things known at the very, there's something known about why a mixture of simple gases with an electrical spark going through it can ultimately turn into something remotely like not really like, but the beginnings of a bacterium. I mean, at that level, some things are understood. And they're understood because the physical laws involved are more or less grasped. There are things understood, some things understood about the basic forms that exist in life. Bilateral symmetry. There's some biophysical things that are understood more or less. But when you ask why particular organs exist, you can't say anything. You can say some weak things. You can say that things won't be around if they're harmful to reproduction, because then they'll die off through natural selection. That you can say. And you can say a few other things. You can say some things about population genetics and so on, but you can't say anything much about these topics. And in fact, I don't think serious evolutionary biologists have any doubts about this. If you want to get a good picture of it from the point of view of one of the best, have a look at Richard Lewontin's article on the evolution of cognition in the third volume of the Encyclopedia of Cognitive Sciences that was published, edited by Daniel Ascherson and other people, published by MIT Press a year or so ago, where he goes on to give I think a very plausible argument as to why not only do we know nothing about the evolution of cognition, but it's not even clear that there's a question there that we can ask seriously. I mean, the reason why we have the kinds of systems we do in the brain is probably because that's the way physics works. As he says, pretty reasonably, for all we know, when the brain reaches a certain level of, maybe, the brain may have gotten very big in order to do things like, to take a semi-joke, which he gives, to cool the blood. I mean, it could have been a thermoregulator. It's not impossible, like Aristotle thought, that the brain was a thermoregulator, cooled the blood. That's why you got so much blood flowing around. When it reached a certain scale and complexity, because of the way physics works, biology works, and so on, it just had certain properties. And one of those properties could have been, sort of ability to solve some kind of problems, or a language capacity, or something else. If cognitive capacities are like other things in the biological world, that's probably the right kind of answer. Now, once some of those capacities were around, it's conceivable that they contributed to differential reproduction, in which case you would tend to have, more individuals around with those properties. But as he points out, even that isn't very reasonable. I mean, if you remember that most of human evolution was sort of small hunter-gatherer societies, little groups of people who were sort of foraging around in the for food and trying to avoid saber-toothed tigers and things like that. And as Lewontin points out, I mean, if you want to you can construct all kind of fairy tales and stories about this. He says, well, how about the following fairy tale? How about the one that says that you were more likely to live and hence reproduce if you were dumber and less imaginative? Now, as he points out, there's some plausibility to that. I mean, if you've got a group of hunter-gatherers and one of them happens to be courageous and, imaginative, and he wants to try to see where that saber-toothed tiger is going and so on, he's more likely to get killed. Now, his presence in the tribe may help the tribe survive, but his genes aren't going to be transmitted because he's more likely to get killed. The ones who are more likely to survive are the ones who are cleverly sitting at home and waiting for him to kill the tiger and bring in the food. So maybe there's selection for stupidity and for lack of imagination and so on, so that then you get the opposite of the development of cognitive development. As he points out, that's as good a fairy tale as any other. And in fact, in this domain, we really are talking about fairy tales.
The richness you describe in language, it sounds like it's something that's in the logical system, and what's in the brain is an imperfect ability to follow that.
the brain has developed all sorts of capacities, many of which are never put to use. I mean, we just know that for a fact. I mean, let's say take another capacity which is more or less well understood, the number faculty. Now it's like the language faculty. You got to know what a number is in order to learn anything about numbers. How does a child know that after it's taught to count to 6, that there's going to be another one? Why didn't it end there, let's say? How do you have the capacities that enable you to comprehend what a prime number is if you get that far? Well, those capacities, whatever they are, they can't be learned because you just think through the logic of it. You can't learn them unless you already have them, the usual story. But those capacities were present in the human species long before they were ever used. In fact, there are human societies today that in their entire, have the same genes we do in every relevant respect, which in their entire hundreds of thousands of years of history have never used it. Although you can quickly evoke the capacity in those species as soon as you present, you sort of give them right stimulations. So these capacities are just sitting there, waiting. I mean, why are they there? Well, probably because they're piggybacking on some other capacity. Like it's been argued that they're piggybacking on the language capacity. And one curious fact about language is it has this odd property of discrete infinity. It's an infinite digital system, which is extremely rare in the biological world. And that's like the number faculty. So maybe the number faculty is just kind of an abstraction from the linguistic faculty that doesn't look at its complicated properties and just looks at its basic structure. Well, that's a nice fairy tale, maybe true. And if so, you'd have a number faculty around long, without it ever being used. And there could be lots of other faculties like that. I mean, the chances are, just on kind of grounds of biological plausibility, that if there is a faculty sitting there that would contribute to reproductive success if you used it, chances are it'll be used. And that's just on grounds of plausibility. Over a couple 100,000 years, somebody would have tried it, and they would have succeeded, and so on and so forth. But that's about the level of what you can say in these areas.
A little while ago, a fairly well-known neural network person, whose name escapes me now, came here and compared rule-based systems to what he did, not using a chemistry physics analogy, but an analogy, and I'm not an astronomer, but something about an older mathematics for figuring out orbits that was fairly accurate, but it didn't really describe the physics of what happened, to a newer mathematics that's more accurate and actually was showing what really happened. I know it's a pretty big and vague question, but do you have any kind of answer to that?
Well, on neural network systems, I mean, there's nothing general to say. I mean, like any other mathematical conception, you can just ask, does a neural network is a very abstract notion. Question is, does it abstract from this physical thing above your neck properties relevant to some particular question? That's what you ask. So in fact, you ask the same question about it that you ask about any computational representational system. Suppose somebody says, well, I think the representations of the brain are in first-order predicate calculus using the notations of Quine's mathematical logic. Okay, that's an empirical hypothesis. And then you can't ask a general question. You can just say, well, is it true? Let's ask whether it's true. And the same about some particular neural network proposal. Now, there are some areas which I don't have enough knowledge about to make judgments, like some aspects of, peripheral visual perception, where people whose judgment I trust tells me that these models have some success. There's nothing to talk about in the case of language. As far as I know, there's simply nothing to talk about. You can't point to something that has any success. So you can't know whether there's any point to pursuing this or not. Maybe there is a point and nobody's figured out how to do it yet, or maybe there's no point. But it has no prior plausibility. It's based on the assumption that this particular way of abstracting from physical systems is a good way. Well, there are endless numbers of ways of abstracting from physical systems. And in fact, as I mentioned, we're not even at all sure that we know what properties of these physical systems are the relevant ones to pick out for abstraction. So all you can do is look at someone's particular proposal.
I mean, I really, actually, I don't agree with him, but the point he was making that I wondered if you had a response to was he felt that his mathematics were very closely modeling what was really happening in the brain, and that made them somehow superior to a model that didn't have that legitimacy.
That could, he could be right, he could be wrong. But the only way to answer the question is to have a look at his mathematics to see what the explanatory framework is and what the empirical successes are. That's the question. In the case, as far as language is concerned, I don't know of anything to look at. Yeah.
I'm just looking for some illumination on one point where you were saying that the idea of a shared language is unnecessary. I sort of hit a wall on that.
Well, let's say you and me. Do we have a shared language?
It would seem so.
Why would it? Are you and I? Do you and I look alike?
In certain aspects.
Okay. Well, we have a shared language in certain aspects too.
Okay.
And the trouble is, there's no topology of those aspects that means anything.
So it's more like what we think of as shared language. If we think of it, would be just aspects of the thing that you call language itself.
We think of things as being near each other too.
Mm-hmm.
Relative to particular interests, we think of things as being near each other. Like, I happen to live in Lexington, and the next town over is Arlington, and I think of Arlington as being near Lexington. But there's no answer to the question, is Arlington near Lexington? It depends on your interest at the moment. Okay. Now, from the point of view, if we have the purpose of, getting along pretty well without too much trouble, you and I share the same language, because we're going to be able to do it. If there's somebody out there whose native language is Japanese, and he starts talking Japanese to me, I'm not going to be able to do it. So from the point of view of that particular human interest, we can impose a kind of metric on the system, if we like. Pick some other interest and you'll do it differently. It's very much like being near. I mean, suppose I ask the question, is John almost home? There isn't any answer to that in general. The question is, relative to what interest?
Okay. So these things are just on a sliding scale and don't fall neatly into categories.
It's not that they don't fall neatly, they don't fall into any categories.
Okay.
They're like height categories. I mean, people differ in height, all over the place. If your interest is putting together a professional basketball team, then you might say, well, there's two categories, above 7 feet and below 7 feet or something. But if you have some other interest, you'll do it differently. There's no answer to the question, what are the height categories? It's just not a sensible question. And the same is true about common languages. Now, we get easily deluded about that because there are things around like oceans and conquests and national TV and so on, which impose, which do impose kind of topology, if you like. But, that has nothing to do with the nature of the language faculty. If you go to parts of the world where these factors haven't operated quite the same, you just get any mess you like.
I do understand that a little better now. Thank you.
Yeah. Oh, go ahead.
Yes, you mentioned about some language utterance are not logical, like you said, near miss is actually near hit. And I can find some other examples in Chinese. If I say he almost didn't come, it's the same as he almost didn't, he almost came, versus he almost didn't come.
Notice again it involves a negation. It's pretty standard and negative type.
Yeah, negative type, but they express the same thing, and also that's illogical. So how to deal with this phenomenon in your mental computational
There's
system?
nothing to deal with. We just observe it. It's like dealing with the fact that you're standing next to a chair. It's just a fact. I mean, we can kind of explain it. I can explain the fact that you're standing there. You wanted to say something. And we can explain this partially on the grounds that our interpretive mechanisms simply block when they're faced with certain kinds of semantic structures. And we can find some of those blockages, like the presence of anything of in any way, negative character, like the word miss is a typical case. Try to ask. Suppose that you go somewhere every Christmas. Let's say you go home every Christmas, and you usually see some friend of yours, and you didn't see him last year, and this year you meet him, and you want to say, I kind of expected you to see you last year, and I didn't. Do you say, I missed seeing you last year, or I missed not seeing you last year? Nobody knows the answer to that question.
Yeah.
I mean, there's got to be an answer. It's determined by the semantics of our language, but nobody can figure it out. You know? And the reason is that words like miss have a sort of a negative aspect to them, and we're just not well equipped to compute that. That's why people have such a rotten time doing propositional calculus. Propositional calculus is one of the hardest things to do. It's the most elementary part of mathematics, absolutely trivial. You can construct an algorithm which will, solve every problem in Principia Mathematica in a fraction of a second, but try and give it to professional mathematicians, and they have a horrible time with it. We're not well equipped to do those problems, just like rats aren't well equipped to run mazes.
Another question. Let's do your famous sentence like colorless green idea sleeps furiously, and many people claim that it is syntactically correct, but semantically wrong, makes no sense. But could I say that it's grammatically right if you say it in an appropriate context? Like if somebody asks me, what are you going to do tonight? I just answered, colors green ideas sleeps furiously.
You can use it in all kind of ways. For example, it could be a code which says, drop the bomb tomorrow. That would be a perfectly correct usage of it. I mean, there's nothing, any human action could possibly have all sorts of ranges of, any signal that we can produce could be used for all kind of purposes depending on tacit agreements or explicit agreements and so on. The question is, what are the properties of that expression? Well, the properties of that expression, in fact, see, here incidentally is a case where the unification issue actually provides some insight. From a computational representational point of view, there are some theories which tell you what the properties of that expression are. When you look at evoked potentials, it turns out that you get some correlations. So expressions of that type, that's interesting. That tells us that, from two different points of view, looking at the brain, we find a categorization that comes out the same. That's interesting. But the general question, is it a sentence of the language? That has no meaning. I mean, there's a perfectly good sense in which an expression of Chinese is a sentence of English. If you were I don't know a word of Chinese, but if you were to say something in Chinese, using my language capacity, I would assign a certain interpretation to it automatically. For example, I would distinguish it from the screeching of a door. Now, suppose that there's a guy over here whose language is Swahili, and he listens to you. That person will assign probably a different interpretation to it, okay? Which means that his language and my language each assign some interpretation to a sentence of Chinese, namely with whatever properties it has.
I have two clarification questions I wanted to ask. The first is about the nature of the language universals as you define them. I'm a little bit unclear on these, and I was hoping you could answer this question about how we are to interpret them as laws, language laws. This is an example you gave. You said that in the two sentences, he thinks John is a genius, and John thinks he is a genius, that in the second one, he, the pronoun, can refer also to the subject, whereas in the first one, the pronoun he cannot refer to
John. Can't be referentially dependent on the subject. Might by accident happen to refer to the same person. But it's not our intention in using it to have to assign he the reference of John, and he thinks that John is intelligent.
All right.
Now, that seems to be universal.
All right. That's okay. Now, do you feel that if I were to create some sort of environment for a language user where I consistently violated this universal rule and made the reference of the pronoun dependent on the name, would that person evolve in such a way, or would they acquire the language in such a way that they would use this, they would substitute the rule, or are you saying that this is a rule that,
in fact,
that we couldn't overcome?
The answer to that, if you think about it, you already know. You know that rule without any experience. It's not that as a child you tried to do it the wrong way and your mother said that's not the way we do it. Okay.
But if I tried to make my child do it the wrong way, would they grow up being able to do
sure.
it?
You could probably raise your child to speak propositional calculus. You know, I mean, it wouldn't be. It might be. You could raise your child not to use its language faculty, but to use other faculties of the mind.
Okay. The second question I had was about your.
I mean, like just you could raise. You know, you could raise a child to crawl instead of walk. Or to say walk on four legs, you know, like a dog instead of walk, and probably maybe would end up doing that and lose the capacity to walk. Just wouldn't be using that faculty.
I wanted to ask you about the performance structures versus a language, and you said that someone could have a language but not have the performance structures with which to manifest it.
In principle, I would rather doubt that that's biologically possible, but you know, you could imagine it as a conceptual possibility.
So you draw a sharp distinction between language and language usage, which would almost account for a sort of innatism where somebody who never had any sort of capacity could still have a language.
Well, we all accept that. I mean, that's not even a question. So, for example, suppose that, say, I have a stroke, let's say, and I completely lose the ability to use English. I can't say a word. I can't understand a thing. Okay, that happens. And suppose that the effects of the stroke are overcome, let's say, by a drug or just through time and so on. And in the period in which the effects are being overcome, I don't hear anything. I have no experience. Well, if they're successfully overcome, if the effects of the stroke recede, or I take the right kind of drug or something, I could, in principle, and in fact it even happens, recover my ability to use English. Now let's look at me during the period when I didn't have the ability. Did I have knowledge of English? Well, the answer has got to be yes. Otherwise, how come, as the effects of the stroke receded, or I took the drug, I ended up knowing English and not Japanese? I didn't have any experience during that period, so how come it came out English, not Japanese? Whereas if it had been my monolingual Japanese friend who'd had the stroke under the same circumstances, he would have ended up knowing English. Those are real things. We're not inventing them. Well, what can that mean? That means during the period in which neither of us had any ability whatsoever, we both had some sort of cognitive system, namely a cognitive system that we couldn't use at all. And later we regained the capacity to use it, and that showed that we already had it. Well, suppose we have now another guy. He has a stroke and he never recovers. But let's say autopsy shows, suppose we're some sophisticated brain science of the future, autopsy shows that that guy has all the same brain structures that I do in the relevant parts of the language faculty. Well, it would be only reasonable to assume that that person retained the knowledge too, though we would have absolutely no empirical evidence for it from behavior. That's just normal science. It's hard to think of an alternative account of this. In fact, I think we just automatically assume it. What we say is that, now in ordinary language, we say that, you know, the people with the stroke know the language, but they can't use it. And they may be able to access that knowledge as the effects of the stroke recede, in which case they will be able to use it. Furthermore, that ordinary description seems almost forced on us, unless, again, you resort to miracles. I mean, you have the problem of explaining why I recover English and my friend over there recovers Japanese, even though neither of us has any evidence. Why didn't it work out the other way around? Why don't I recover Japanese and he recover English? I should say that this issue's come up in the philosophical literature. People like, say, Anthony Kenny, Wittgensteinians of various types, who wanted to claim that knowledge is ability, have given some very strange answers to this kind of question, which in fact amount to inventing a new kind of ability, different from the usual kind, which is invested with all the properties of knowledge. You know, that doesn't get us anywhere.
Yes, sir. I would, over here, would like to ask a question. I'd like to know if there's any evidence that the real, the world, can influence or inform or change the actual or the phenomenological. For example, or for instance, can the signifiers we use to stand for the spoken signifiers we use to stand for the noise a dog makes actually inform the noise that we hear that the dog makes?
Yeah, it may very well be true. Like it may be that, we hear roosters saying cock-a-doodle-doo, and some other language they hear them saying cuckoo-ree-coo. And maybe you could even show that in an experiment. I don't know of any experimental results, but I would imagine it would be true.
Thank you very much.
Every time I hear about your assertion that certain principles of language are innate, I can't get over my response that that seems an explanation of sorts of last resort, and I keep wanting to say instead that we have not yet figured out how we can extract those principles from experience. And
that's a common reaction, and I think it's an interesting fact that people have that reaction. So in fact, what you're saying is very characteristic, and it's an interesting fact about the intellectual culture, which goes back hundreds of years. And notice that I assume you would have a very different reaction to say, let me ask you the following question. Suppose that, as far as I'm aware, nobody knows anything about the biological factors involved in puberty. Okay? Now suppose that somebody comes along and says, but also as far as I'm aware, every developmental biologist assumes that puberty is basically programmed. I mean, it'll happen, or, when it'll happen can be affected by nutritional level or something and so on. Suppose somebody came along and said, well, that's an explanation of last resort. It really results from peer pressure, but we just haven't figured it out yet. I mean, it really results from the fact that, these young people, 10 years old, see their friends going through puberty and they want to be like everyone else, and that's why they're doing it. Okay, well, that's conceivable. Now, the point is, when you make that proposal, everybody laughs. When you make the comparable proposal about anything sort of above the neck, to put it metaphorically, everyone thinks it's very reasonable. Now, the question is, what's the difference? Why do we think it's ridiculous in one case and plausible in the other case? As far as I know, the evidence is about the same. In fact, the evidence for innate structure is probably better for things above the neck, because there we're not in total ignorance. You actually have some strong proposals about the innate principles and some explanatory force to them, too. So by the standards of the sciences, at least, we have more reason to believe in the innate principles above the neck than below the neck. And in fact, they also did in the 17th century. The one case that I mentioned, if you go through it more, it's more convincing, about Descartes and Hume, is an example of that. There were some phenomena around. Everyone agreed on the phenomena. There was very strong evidence by the criteria of the sciences to take Descartes' solution that it's innate. That's why it happens. Nevertheless, the long-term consequences were acceptance of Hume's solution with its self-refutation that we don't have the concept of a straight line. Now, I think that reflects that same strange intuition that people have. Above the neck, we insist that everything's got to be experienced. Below the neck, we're quite willing to accept the idea that everything is the way any rational person would think. If you have things that happen without information, it must be coming from inside. And I think the question is, why the dualism? Well, if there were any rational support for it, you could look at that argument, but there isn't any. What it comes down to is exactly the feeling that you express, and that's the standard opinion. So we have to ask a question about irrational attitudes. Why this particular irrational attitude? And that's what it is. And you could have various speculations about it. My frank opinion is that it's a reflection a kind of something which also showed up in traditional dualism. So, I mean, as humans, it's very natural to think of people as having a mind and a body which are separate. And there's a problem about how to connect them. You know, traditional mind-body dualism was very commonsensical. I think that probably is the way we think about people. That's why we would regard someone as being the same person if their body underwent all, you know, what we call their body underwent all sorts of changes, but we would think of them as a different person if you recoded their brains and they had somebody else's memories and language and thoughts and so on. Okay, that's just the way we look at people, and it's very hard to get out of it. Just like it's very hard to look at the sun setting and to tell yourself it's not setting, the earth's turning. I mean, you sort of know that at some level, but there's no way for you to look at that and stop seeing it as the sun setting. You just can't. And I think when we look at people, it's extremely hard for us to look at them and not see them as minds inside bodies. Well, traditional dualism, metaphysical dualism, collapsed for scientific reasons. But that doesn't mean we can get out of our skins. We still look at people this way. And I think what has replaced traditional dualism is a kind of an epistemological dualism, which comes out pretty much like this. It says, below the neck, I mean that metaphorically, like, you know, on the things that people call physical, we're willing to pursue the methods of the sciences. And if they lead us to conclude that things are internally programmed, we'll accept it. Above the neck, we're going to be completely irrational. We're going to insist on what we would never dream of in the case of things that fall on our side of the intuitive boundary physical. And I think that's probably correct. I don't see any other way of explaining this strange phenomenon for the last several hundred years, that the very same kind of evidence, in fact even better evidence than that which would make us laugh about puberty and peer pressure, has made people think we can't do that in the case of mental activity. If there's another explanation, I don't know it, but I think we're in the domain of trying to account for irrational human beliefs.
Is that it does seem to me that when I ask linguists this question, I really appreciate your full answer, because very often I get the answer, if you won't even accept what I say that far, then we have no grounds to continue the discussion.
That's the right answer. No, why should you accept what any linguist says? Or for that matter, what any physicist says? I mean, if a physicist, if you asked, let's take my hypothetical story about, you know, opening up this month's physical review and my looking at an article which looks to me like gibberish, and I go over to the physics department and I ask some friend over there, tell me what it's about. If he just says, look, take my word for it, then I don't trust him. I mean, I may decide he's a postmodern theorist, you know. If what he tells me is, if he does what in fact he can do, you know, find my level of ignorance and give me some account at my level of ignorance which will introduce me to what's going on and even explain to me a plausible way in which I could go further, then we're in business. And I think you would have the same reaction to those linguists. I don't think all this stuff is that deep, you know. It's not physics. It's much simpler than that. And it seems to me it should be possible to give answers at the level of understanding of anybody. I mean, I've talked about these topics in junior high.